Good morning. This is Alcindo. I think may wait for another minute or so for some other people to join, and then we'll start. Okay, so welcome to our webinar. I'm Alcindo. I also have James Rose with me. He will monitor any questions and interrupt me if necessary. Well, everything about fiber may be an overstatement, but it's most of the stuff that I discovered, found out, was confronted with in my previous job, which had much more to do with optical fiber stuff than what I'm doing now. So the presentation covers the following subjects: the structure of fiber optical cables, the different types of glass fibers like multimode and single mode, connectors, optical transceiver modules, and we will start with optical fibers. So optical fiber for data communication can be found as patch cables like in the top here, or in bundles, which is more like this. And if you have the patch cables, you can have a single one or a double one, or in some cases even a four side one. So they can have connectors on both sides, but like the bundled one, those do not have connectors to start with. In the bundles, you have the hard core and a sheet, and the fibers themselves, you have four layers. You have the core, which is very tiny, or at least the diameter is very small, which is in usually micrometers. That's where the light passes. You have the cladding. That's the part that reflects the light back to in the core when it tries to leave. You have the buffer, and around that you have a jacket. So in total, you have something which is about a millimeter thick. When you look at what the description on the cables, you will usually see numbers like 9/125 or 50/125, which are the core and the cladding respectively. So about multimode and single mode, optical fibers of course have several advantages over copper. It's electrically decoupled. If something fries because of a over voltage, then it will only stay on the one side because the optical fibers will not transmit the voltages. It's suitable for longer distances than copper Ethernet, which is also probably the biggest plus and the reason why we're using it. There are different types of fibers, each with their own benefits and uses. We have multimodal fibers, which usually see something like MMF or MF as for short. And you have the single mode fiber. So the multimode fiber is cheaper than the single mode. You should consider this to be used for local area networks or semi-local areas, and you have the single mode fiber, which is for longer distances, like kilometers instead of hundreds of meters, and so it's more of like for wide area networks. So for the multimodal fiber, these are cheaper. They're cheaper to produce, but it's very important to remember that while at first the fibers, the prices in fiber were quite great, like factor 3 or more, the difference has come down significantly over time. So now single mode cabling or fibers are almost as cheap as multimode or as expensive, depending on what you're looking at. So if you have the multimodal optical fibers, they are only suitable for shorter distances, like 300 meters or 550 meters. There are some combinations that you can even do 2 kilometers with some special modules, but usually just think about hundreds of meters, like 300 to 550, depending on the modules and the fibers you're using. So the fiberglass of the fibers has a diameter of 50 to 100 micrometer. And this is much more than the wavelength, which is about 1 to 1.5 micrometer. And this is something we'll come back to later. The biggest issue we have with multimodal fiber is something that's called modal dispersion. So if light goes through glass, of course, if you have very thick glass, it will dim or attenuate the strength of the glass, and it will also slow down the speed of it. But the most important thing is the modal dispersion. And the modal dispersion, I'm trying to show it here in the picture at the bottom. And that is that if the photons go into your fiber, they may bounce around in the fiber. You have to see the fiber like a tube, and the photons like little balls that can go from one side to the other side. If they go straight through, they will go through faster than if they do lots of bounces. Then they will take more time to get to the other side. And this makes that if you put in a pulse and the photons in the pulse go in different directions, then on the other side, it will not be a nice square pulse, but it will be spread out. And I have another picture later showing this a little bit more clearly. So you have this picture here. So each of the pulses has multiple photons in different directions bouncing around in the tube. And then on the other side, some of them will be very fast, arrive very fast, and some will be average, and then some will be very late. And you can see that if you put in additional pulses, then you will have them smeared out, and then at a certain point you will not be able to distinguish between the other side. Now it's very clear, there's a pulse, there's a pulse, there's a pulse, but if you put in additional pulses in between, then at a certain point you will just have one smear, and then you will not be able to see the different pulses anymore. So the longer the distance you cover, the more this effect occurs, and this is the limiting factor that will cause the distance of the multimodal fiber to only be hundreds of meters. So if you increase your data pulse, it reduces your maximum distance you can cover. There's one way sort of around that, and that's make the tube sort of that if it goes in the middle, it will go slower, and then when some photons go on the outside, they can speed up. And this is what they do in graded index multimode fiber. But as you can understand, producing graded index multimode fiber is not cheap, at least not as cheap. It's more expensive than the normal multimodal fiber, so it's not very popular. And I don't even remember seeing anybody selling it, but that's something else. So by changing the properties of the glass, you can make it go faster on the outside than on the inside. On the outside, they go a little bit faster. On the inside, they go a little bit slower, and that makes them come out a little less smeared than before. If you had a perfect graded index multimodal fiber, you will have a perfect pulse in the other side. But probably the cost of that would be much more expensive than the other solution. There's another thing. I haven't seen it being very popular, but we also have plastic optical fibers, which should be cheaper, and in that case, the fibers are not made of glass, but of some plastic polymer. This would make it much cheaper than the real glass fibers. Also, the connectors are cheaper, and it will be much thicker. So that's the reason that it's also multimode. But plastic does not pass photons as well as glass does, so it will have more attenuation, and because of that, you can only use it for very short distances, maybe in small buildings or houses, like stuff like that. Then we come to single mode fiber. You already see the track. It's more expensive than multimodal fiber, and it's suitable for longer distances. And we're talking about kilometers, 10, 20, even 160 kilometers in some cases. the difference between multimode and single mode of fiber is that the fiber core diameter is only 5 to 9 micrometers. That's about 10 times to, or that's less than 10 times the wavelength of the light. And at a diameter of less than 10 times, the photons start to behave as a wave instead of particles. They will not pass each other. They will have the same speed, and that's why you have the tracks here. They will just be photons on track. The photons will just go behind each other and stay behind each other. So you will have no smearing. You will still have attenuation. So it will be dimmer if the fiber is longer, but that will be the only effect. You will still have a pulse on the other side, and if the length is more, the pulses will be smaller and smaller and smaller until you cannot see them anymore, unless you use a more powerful laser at the start. The limiting factor is mostly the attenuation of fiber. So if you have fiber that has less attenuation, you can cover a longer distance. There's also some special version of the single mode fibers, which is not a fiber. In that case, we have a hollow core. So instead of glass in the core, there will be air, or maybe even without air. And the difference is that glass has a refractive index, and because of the refractive index, it will be at the speed of light will be reduced to about 2/3 of the speed in vacuum. And if you have no glass, like a vacuum or air, it will be about the full speed of light again. Or actually, if it's vacuum, it will be the full speed, the full 300,000 kilometers per second, or whatever it is. So 200,000 kilometers seconds in glass, and 300,000 kilometers in seconds in vacuum, or in air, a little fraction slower. You can increase the speed of the photons, and if you have a distance of about 600 kilometers, it will take 3 seconds for the glass fiber, but 2 milliseconds for the hollow core. And if you're a trader, stock trader, and you're based, one is based in New York and the other one is based in Chicago. If you know the pricing changes in New York, you can trade on that in Chicago. And if you know a few milliseconds before the other guy, you make a lot of money. And this is the reason that they really put in these kinds of fiber. The only drawback of this is that the vacuum or air attenuation for these types of fibers is much higher than for glass fiber. So you need more repeaters, which will also cause some delay again. So glass fibers are used in different ways. We have them used as pairs with a single color of light. One fiber for one direction and the other fiber for the other direction. We also see that used as one fiber in with different colors of lights, and then one color is used for transmitting on one side and receiving on the other side, and the other color is used the other way. So this will have as a bonus that you will only need a single fiber to have your data going both ways. but what you need to connect to them will be a little bit more expensive. There's also the ability to use one fiber with 3 colors of light. Then you have one color for data one way, one color for data the other way, and one color to modulate your analog TV signals, which in this case will be one way only to the customer. This is popular in some for some ISPs where they want to provide analog TV signals to customers and not do it pure using data. And then we have the two fibers with many colors, using wave division multiplexing. Then you have each color for a different different data paths. So if you have 4 colors, you can do 2 colors for data up, 2 colors for data down, and at the same speed as before when you are using only one color one way and one color the other way. I'm not sure how many waves many colors they do, but I think it's like 16 or 20 that they can multiplex in a single fiber. We have some common connectors. So we have the Lucent connector, which is pretty tiny. It's I think it's about 4 by 3 millimeters or something like that. So this is less than a centimeter. And these you can click into a single SFP. In some case, you use it as a duplex, a double version. That is when you use only one color. And if you use 2 colors over fiber, you will have it in the simplex version, so just one. Then you have the bigger standard connector, or SC. 2 of those won't fit in a SFP, so you will see this in SFP sometimes, but it's always when you have used 2 colors. So this is it's a little bit bigger, but in the past we used the bigger modules, so it was not a problem when you use the GBICs. These are also quite common in old existing installations. So you have the through connector. This is something that you screw on, and you have the straight tip or bayonet fiber optic connector, which you can click on with the bayonet system. In some cases, if you have installations with patch systems using these, you can find patch cables that have the one on the one end and the more modern ones on the other end. So you can still work with old systems. So attenuation of fibers. So in 1968, we had 5 dB per kilometer, and so this was impacting our range. In 2013, it was only 1/16 dB of a kilometer, at least in the laboratories. And the actual attenuation for that, what we're rolling out now, is about 1 dB per kilometer. But in some cases, if companies want to stretch, they can use more expensive single mode fibers to stretch the length. In the other cases, if you have the different SFPs, if you put in more power, as long as the fiber doesn't melt, you can cover more distance by just pushing in, letting the laser pushing more light in. Connectors and welds also provide damping, attenuation, and you should calculate with something like 0.2 dB for each connector or weld. One important thing is that the glass, at least the glass that is used for optical fibers, has attenuation which is lowest at the wavelengths of 850, 1300, and 1550 or 1490 nanometers. And that is also why these are the colors or the wavelengths that are used in SFPs usually. It's very important to remember that it's infrared. It's not a wavelength that we can see. So looking into a fiber to see if it lights up is not a good idea. It can and probably will damage your eyes. Just like looking into the sun is not a good idea. If you look at modules, you will always see, for single modem modules, you will always see something like -10, -5, -20 behind this, and that's usually the amount of kilometers that they are rated for, based on the normal attenuation. Can you use the shorter modules or the modules on shorter cables, shorter fibers? Yes, you can. In the past, I was warned that there was a chance of burnout, but nowadays I think that has solved itself. And when the two start to talk to each other, they modulate their output power to a correct value to not burn out the other side. In any case, if you really think you need it, there are fixed attenuators that you can put in between to make it less to do more attenuation on the fiber. But I don't think that's needed anymore. And for those attenuators, you can just tell if you want 5, 10, 20 dB of attenuation. And again, think that 1 dB per kilometer is the norm. So about cables. When you look at cables, you can usually see some text on it and also a color, both a color of the connectors and a color of the cable itself. If you look at the cable, it's often marked with values, and depending on the values, you can tell if it's single mode. If it's the first value is low, like 9 or 10, it is single mode. If it's 50 or higher, it's always multi-mode. And yeah, some just mark them as being SM or SMF instead of putting the values. Or in some cases, you will see both the value and SM and SMF marked on it. In this case, you will see a cable here that has the older standard connection on connectors on one side and a pair of lucent connectors or LC connectors on the other side. Most of the cables, they have a little cap on it that you can well, you probably will not see it very well, but it's a little white cap in this case that's on it. If you put it connected with the caps on, it won't work if it's possible at all. So you have to take those off before you can connect them up. And if you disconnect them, it's very good to put in the plugs again to make sure that the end does not get contaminated with dust or something like that. And the other thing is the fibers. It's very mean stuff. If you poke yourself with it, it will break, and you will have a little sliver of glass in your finger or something like that. And because it's so tiny, it will be hard to see, but it can still hurt. So be careful with. Do not touch the ends. So the cables, what is it? Can you tell from the colors? Or actually, you can tell from the colors. So if you have a yellow buffer jacket outside, so if this part is yellow, then it should be single mode. Optical single mode version 1, 1A or 2, actually. If it's orange, it should be multimode, OM1 or OM2. But again, you could usually it's also printed, so you can double check that. If it's aqua, it's also multimode, but then it's rated for 10 gigabits. If it's lime green, it's multi-mode, again 10 gigabits. If it's gray, this is for all the cables mostly. It's also multi-mode version 1. The blue one is single mode fiber. And on the other hand, from the connector from the boot, you can also see have some information. If it's gray, it will be physical contact or perpendicular physical contact, 0 degrees, and it will also tell something about the other part, the fiber itself. If it's blue, again, it's 0 degree perpendicular, and in this case it's single mode. If it's green, it's also single mode, but in this case angular. This is what we often see with connections with ISPs, at least in the Netherlands, but I expect that will be the same outside the Netherlands too, that your ISP has something that you need to plug in a cable with a green connector on one side. So green on the side of the device that the provider puts in, and blue on the side of your, well, let's call it a modem. Aqua, it will be multi-mode, and they are more or less in agreement with the colors of the fibers or the buffers of those. Black is also physical contact, and we have the white multi-mode. The ones that I see most are the green and the blue for single mode, and I think I see a lot of the badge ones. So the first 3 are the most common, and in the case of the fibers, I think the first 3 are the most common that you see in the field. And the red high power, it's there, but I've never seen it. So this is when you use really powerful lasers, so that the connector won't boot. It's not just about the glass not melting, but also your connector should not melt. So I already had talked about PC, UPC, and APC. So PC physical contact, UPC ultra physical contact, and APC angle physical contact are polishing styles inside the fiber optic connectors. The main difference is that for APC, the so-called back reflection, if you have a a end to a fiber, because it will change over from one side to the other side, and it will have, well, no, ideally nothing in between, but it's just like if you're looking through glass, you will still see that the glass, and you might even see a reflection of yourself in a window. The same is also true for fiber. So some of the photons will be reflected back, and for the physical contact, or the not angled, the perpendicular one, that will have more back reflection, or better visible back reflection, than if you have a small angle in it. And that's then less impacted, or not impacted, by repetitive removal and reinsertion. However, in most cases, if you plug in a fiber, it's there to stay, and you will not remove it very often. So the perpendicular is impacted more by repetitive removal and reinsertion. There's also something about the differences, that UPC has less back reflection than the PC variant, and APC is even better than the UPC. So the more minus, the better. So then we have the cables, and we have the connectors, but still have to go into something. So like something like a switch. So there are optical fiber switches, but in the case of the optical fiber switches, they do not have connections for fiber out of the box. They have cages, and in those cages you can put optical transceiver modules. The modules contain the lasers, the transmitting laser diodes to transmit and receive the optical signals. So then you need the transceiver modules, and the most popular of those we have are, of course, the SFPs. And they, well, when you put them in, you will need two, one on the one side, one on the other side, and they will need to be the same, and they will need to match the type of fiber. They need to match the colors and stuff like, and also the transmission speeds. They are not very big, the SFPs that we usually use, just over a centimeter wide. So it's and also just over a centimeter high. It has two sides. So this is the fiber side on the left, and you also have the electrical side. That's the part that plugs into the your fiber switch. There it's important that the switch recognize the device using a microcode, and also that the correct speeds are accepted. Well, many switches, they only accept the one speed. So if you have a switch that supports 1 gigabit modules, and you're trying to put in a 100 megabit, a old 100 megabit SFP, it will not work. And if you put in a 10 gigabit, it instead in a normal SFP port, it will also possibly not work. And the other way, if you put a 1 gigabit module in a 10 gigabit port, it might also not work. In some cases, it's compatible. Then it will just choose the slowest speed that's supported, but you will have to check this either by asking the vendor, like us, or by just testing it, which is probably the best way to do. So you already had something about the dimensions of our SFPs, or small form factor pluggable. So it's about 5.5 meters long, 1.5 meters wide, and 1.25 centimeters high. And in this case, you will see this is a duplex version, so single color and both way, and they will look the same to us if it's multi-mode or single mode. We will not see any difference from this, either multi-mode, single mode, or the speed. From the module size itself, you cannot see that. Some people still call them mini GBIC. Some people even call them GBIC, but that's not true, because the GBICs are at least twice as big as these SFPs. But I have a picture later about the GBIC. They're all intended to be hot swappable, so you should not need to power down your switch to remove or insert a SFP. Depending on the color of the lever, so there is a lever on the device to lock it into place and also remove it. You can tell something about the SFP. So it's not just the fibers and the plugs that have some marking that you can use to recognize them, but the same is also true for the SFPs by looking at the lever. So if it has a black or beige lever, it is usually this 815 nanometers, which is very popular for multimode, up to 550 meters at 1 gigabit, or 150 meters. So a shorter distance for a higher speed. But with Ethernet, we will not use this speed, only the 1 gigabit speed. And so this is something like the gross speed. We will for Ethernet we use 1 gigabit. So many modules only work at a fixed speed. There are some modules that can do both 100 and a gigabit, but you have to look out. And also many receptacles, as in switch cages, also only support a single speed. Again, if you want to know for sure, just test it. Electrically, there's nothing that you can break. The worst thing that can happen is that it tells you I do not recognize it, or it doesn't work. So again, with a single mode, you will can find them with blue levers and LC connectors, and then they're for the LX models, they are 1310 nanometers. The 1310 and 1490 and 5050 is used usually for single mode, and then it's up to 10 kilometers. Like I said, if you look at the labeling on the device, usually you will see -10, -20, -40 for the range. And if you look at most of the SFPs that you can buy, they are usually -10 and -20. If you go to higher speeds or higher distance, longer distances, -40, -80, -160, expect to pay a lot more. So for the longer speed, the ZX 1550 nanometers is used, and then you have 80 kilometers, 120 millimeters, and then we also have the BD or bidirectional devices using a single fiber. Those are 1490, 1310. You need a pair, and they have to be matched. So one size 1490 transmit, the other is 1490 receive, and then the 1490 transmit receives on 1310, and the other one sends on 1310. In the Netherlands, we also see some modules that are 1550/1310. So it's the same. And for my experience, in most cases, those will work. So if you have 1490, 1310 on one side and 1310, 1550 on the other side, it will also work. The reason that you would want to use 1490 is that the 1550 is often used for telcos for analog television signals, if they still use that, because we are also seeing a very clear movement to IPTV, and then you will not have the analog TV signal anymore. So we also have the single fiber, single wavelength thingy to use more speed. The wave division multiplexing, again, multiple wavelengths to the same fiber to achieve higher throughput. So where we have different nanometers here, you can probably add some additional. So the SFP modules, well, we already talked about this one. We can have then woke like this one with LC connectors, and if it's a bidirectional, it will have a SC connector, so you will have only one connector here. And we also have the Ethernet variant, so an SFP, which has an Ethernet version. This is very handy because it provides you with a little bit of flexibility. That if you have a fiber switch which only has cages and not an Ethernet connector, you can still use that. Use a copper SFP to plug into one of the ports, and then use that for short links, like linking your computer up to the switch to manage it over Ethernet locally. So we talked about SFP, and we have SFP. SFP is always one slow, like 1 gigabit at speeds, or 100 megabits for the older ones. SFP plus, it's the same physical size, but it supports 10 gigabit. And again, just like the SFPs, we can have them in all kinds of flavors: single mode, multi-mode, Ethernet, wave division multiplexing, etc. In some cases, you can have your SFP module, SFP plus model, work in SFP cages, and on the other way around, there are also some SFP modules that will work in SFP plus cages. I have seen that working in some cases, but only after that you force the line speed on the switch to 1 gigabit, or the switch will try to do it on 10 gigabit and fail. So some different other ones. The most on the right, this is the GBIC module. So we have the SFP on the left, and on the right is the GBIC module, which you can see is much larger and this one will support 2 standard connectors to plug in. We also have the XFP. I think that's this one. So the second one from the right, and QSFP is probably this one. It has the same physical size as an SFP, but instead of 2 connectors or two fibers entries, it has 4. So this is something that might become, if it isn't already, very popular with ISPs. And of course, we have to talk about the direct attach cables or passive optical cables, whatever you want to name them. So you have no electrical isolation using this. That's important to know as a distinction. And it has all kinds of names. But the big thing about this is that if you have a local, have multiple switches with SFP plus ports, then you can hook them up with the use of this a cable like this, which is much cheaper than the usual using fiber, and also it's more rugged in some things. So these are soldered together. There's nothing for you to plug in except one end, plug it into one SFP cage, SFP plus cage, and the other side on another SFP plus cage. The passive versions are up to 7 meters. You will often see them 1 meter, 3 meter, 5 meter. And they're also active cables. I haven't really seen them being sold yet, but I wasn't really looking in any case. So just one cable to connect 2 switches. And well, they talk about it being an alternative to some other type. So if you have an SFP into your switch, depending on the switch, you can read out some information from the module using the Digital Diagnostic Monitoring Interface, DDMI, or the Digital Diagnostics Monitor, DDM, or Digital Optical Monitoring, DOM. Depending on the vendor, it will have these different names. It's an industry standard, and you can check out some information like the temperature of your SFP, the optical input and output power, and it requires to be supported by both the switch and the module. So there are a lot of modules. The cheaper modules maybe will not have this. So this is optional. It's not a requirement. But if you want it, you will need to check the specifications of the devices that you're buying if they support it. So if you look at one of our switches, like the ECS 1528 FP, it can show you information about the about the module, the wavelength that is used, and also on the other side with DDM, it's for the voltage, the temperature, and some other information, which can be very nice. So I have some troubleshooting things that I found. If you have bidirectional simplex single fiber 2-color thingies, check the one side and the other side are really reversed, that you have the correct pair and not both have the same values for receive or transmit. Because if they have the same values, then you will not be able to see any. If it's sending on the same color and is trying to receive on the other color on both sides, you will not get any data through. So check that. Often, if you can buy them as a pair. In some cases, your ISP already has one side, then you need to find the matching one for the other side. So if you have duplex, one color, two fibers, if it doesn't work, check your cable. If you look at the cable, then you will see that with this cable, I'm not sure if you can see the colors, but this one has white and yellow to mark the different fibers on one side, and on the other side is the same. But this is obviously a crossed cable because it goes from white on the left to white on the right on the other side. You can often break the part that's holding the two LC connectors together, also with the SC connectors, and then you can try to switch them from side and see if the straight cable works. This is very often the case that there are something wrong with the patch that somebody made a mistake putting in the cable and made so then you will get a situation that it's receive on receive instead of receive on transmit. So swapping the connectors can make you find out if that's working or not, or if that's the reason that it's not working. In any case, if you can, check the diagnostic. Check if the fibers are the same type, and also the SFPs are correct. So everything needs to be single mode or everything needs to be multi-mode. Check that they're rated for the same speed. If you want to have 100 megabit on one side and gigabit on the other side, unless the gigabit one wants to work at 100 megabits, so it's a multi-speed one also, it can also work the other one, then you can have a problem there. Check if your cages support the speed that you're trying. It can work, but it's not a given. Try if you can get a link by forcing the same speed, like I said before. Some cases you can get SFP Plus to work with 1 gigabit on the other side, but you need to force it to 1 gigabit. And the last trick, the dangerous trick, is take both SFPs, plug them into a switch, and well, if it's a fiber module, plug in your patch cable without looking into anything and see if it links up. This is dangerous because if your switch is not configured against loops, then it will you might need to remove it very quickly again. But the nice thing, of course, is that it's hot pluggable, so that's not really a problem. But usually, if the patch cable is okay and SFPs are okay, you should get a link in if you do it in the same switch. If you use a passive optical cable, direct attached cable, it will not be supporting TDM. So you won't see anything about that. It doesn't have a temperature or voltage that it can show, but it will show the nominal bit rate of your device and your compliance thing. And it will also give you a fake laser wavelength. Not sure why it does, but okay. Then in the switches, we might have switches that have dual personality ports. And these ports are the same ports, duplicated SFP port and Ethernet port, but you can only use one. And you can recognize these by them having the same numbers. When no SFP module is connected, you can use the Ethernet port. So these switches can also partly be used without SFPs. Some switches have versions with and without dual personality ports. I don't think EnGenius has any of these. They're all either SFP or Ethernet, so always different numbers.
Right.
And in some switches, you will have from other brands, you will need to put in a plug-in card before you can put in some of those modules. So if you want to deploy them, it's not as easy as mounting as an RG45 plug. It requires expensive equipment. For loose fibers, just a very tiny one, they are usually blown. And splicing two glass fibers together, you will need expensive equipment. These are thousands and thousands of euros to buy. So unless you're doing it very often, hire someone to do this. But often, especially in local settings, you can get away with ordering a cable with plugs already mounted on them, and then just then they will also have something called a pulling sock, I think, and then you can just pull it like a cable through the pipes from one side to the other side. But the pipe needs to be wide enough to support your plugs, of course. Also, we have something called passive optical networking. Everything we're talking about now were active point-to-point active optical network solutions, or AON, whatever you want. And so passive, well, it has lots of different names and variants. And the idea is that you will have optical splitters using different wavelengths, and different wavelengths come to the different customers, or in some cases, but that's not this type, they will not use different wavelengths but time slots. So you have the optical line terminators, which are on the side of the ISPs centrally, and the optical network units, which are the customer sides. And you have the optical splitters, which may be in street cabinets or even underground. And then you have a very few lines on the OLT, and then split off to the different sites, the different houses in the street. And if you want to support additional houses, you can just put in a additional optical splitter, which will reduce your length or distance that you can cover, of course. So each optical network unit has its own received color, but all has transmit on the same color to back to the ISP, and they use specific wavelengths for upstream and downstream. So you need less fiber in this case. It's easily scalable. but it's a pure ISP solution. Disadvantages because you're using the same fiber for multiple people. It's a shared medium. You have greater risk of eavesdropping, and they are really expensive to put in. It's not like a fiber switch that, like we talked about before, that has lots of cages and you only need to fill in those cages for the customers that you have. So what to do, what to choose? PON is mostly for internet providers or very large deployments. Active optical networks in most, if not all other cases. Multimode, well, if it's already there, maybe you can just continue it. If short-term cost is the only concern. In the past, multimode was much cheaper, or maybe I should say single mode was much more expensive than multimode. But at present, the differences are not that large anymore. The fiber is still a cost up, but I think that if you look at the modules, then in some cases, some multimode modules are more costly to buy than some single mode modules. So the difference is on the level of the modules is not that big anymore. So single mode in most, if not all other cases. Also, multi-mode will support less distance and less speed. So in some cases, maybe you will even need to rip out the deployed stuff and replace it with single mode to go from 1 gigabit or 100 megabit to 10 gigabits or larger speeds. I haven't seen any questions. So if anybody have any questions, any comments, anything that was unclear, oh yes, if you look at the, I'm not sure exactly where it is, but I have shared this as a PDF already as a handout. So there's a handout section somewhere in the thing you started where you should be able to download it. And there should also be a recording of this available real soon. Well, I get one question about the dual personality. Let me scroll back to that part. So what you have with the dual personality, it's not that the SFPs are dual personality. The SFPs are single personality. They're what they are. That are the cages, or better said, on the switch you will have a cage and you will have an Ethernet port, and both will be branded like 25 on something like a 26 or 28 port switch. So you have 24 Ethernet ports, and then you have 2 ports branded as 25, 2 as 26, for instance. And then one of those 25 branded 25 is an Ethernet port, and there's also cage, which is marked as 25. And the same, you have a cage marked 26 and an Ethernet port 26. In that case, you can choose to use the Ethernet port and leave the cage empty, or you can choose not to use the Ethernet port 25 and 26, either one of them, and plug in an SFP in the 25 or 26 cage, and then use that. So that's the dual personality port idea. I hope that's clear.
Some other brands, they may call it combo ports.
Combo ports is another thing. Yes, you're right. But in that case, because you can recognize them, they have the same number, so you can only use either the one or the other. Either you use it as an Ethernet port, or you use the SFP in a cage, put the SFP in a cage, and then use the SFP port. Yeah, I think this. I don't see any more questions. I think this concludes the thing. If you think of any questions or have any suggestions or remarks, just send those to support@engeniusnetworks.eu as usual, and I will see if I can find an answer to them. Thank you very much. I overran my time a little bit. I went too slow, but okay. Thank you for your attention, and have a nice day.
Bye. Thank you.